In section 3, we're going to learn how to deploy each microservice to our Kubernetes cluster. In Kubernetes, the smallest unit of deployment is called a pod. Some people might think it's a container, but it's not. So the smallest unit, it's called pod. And a pod essentially is a set of containers that are co-located and share the same context, which means, Linux namespaces, C groups, etc. So basically, if a pod contains 3 containers, these 3 containers would always be deployed together and they will always move around the cluster together. Now, the issue with deploying a single pod is, imagine a scenario where you have a pod running on a node and that node goes down. Unfortunately, your pod is gone and Kubernetes would not bring it back. So if you want your pods to be rescheduled when a node goes down, for example, you need to assign a controller to your pod. In the past, that resource or controller was called a replica set, but later on they developed another controller, which is essentially a replica set, but it has a few more features, and that controller is called a deployment. And that's exactly what we're going to be working with in this section. Now, in theory, it is possible for you to deploy a pod or a deployment using the command line kubectl, but the best practice is to have everything in code so you can version control it. So this file, where you're going to define all of your Kubernetes resources, it's called a definition file or a configuration file. And basically what we're going to be doing here is to create a configuration file for each one of the microservices. For now, we're going to write configuration file for 5 of them, which is the front end, auth API, to-dos, users, and log message processor. Redis, we're going to be doing that in section number 5. So let's start with the front end. So this is the repo Kubernetes CTF. I have it open on my Visual Studio Code. And so in the front end folder, I'm going to create a folder called K8s, which is a short for Kubernetes. And then inside that folder, I'm going to call the file deployment.yaml. So in Kubernetes, you can use YAML or JSON to write your configuration files, but Kubernetes suggests to use YAML because it's more human friendly. And this is how a configuration file looks like for a Kubernetes resource. So first thing we need to do is to declare the API version. And for each resource, it might be a different API version. For deployments, the API version is called apps/v1. And then after that, it needs to define the kind. So in Kubernetes, you have different kinds of resources. So like I mentioned, you could have a pod. In our case, what we want is something called deployment. But then later on, you see that we're going to be doing other kinds of resources like config maps, secrets, services, network policies, and so on. So here what we want is a deployment. And then the next thing is the metadata of the deployment. And under metadata, I can define the name of my deployment. In this case, I'm going to call it front end. And another important thing is the namespace. So in my cluster, every single team will have their own namespace. And for demonstration purposes, I'm going to be team number 1, which means that the name of my namespace is called team 1. So here, if I declare namespace team 1, that means when I deploy this, that's going to go to the team 1 namespace. Then after the metadata, we have the specification for the deployment or spec. I can define a lot of things, but to make things simple, we're going to define replicas. And this means how many copies of the front end do I want to run? Right now I'm saying I want to run a single copy, but if you wanted to run 10 copies, for example, to scale it up, you can just specify 10 here. And then Kubernetes will make sure that there's always 10 copies of the front end running. But let's just go with 1. Then another important thing is called a selector. And to understand selectors, imagine that you have a cluster with 100 pods. And you want this deployment to control 10 of these 100 pods. Now, how can you tell Kubernetes that this controller is supposed to control these 10 pods and not the other 90 pods? Basically, we use labels. So labels are key value pairs, and I need to specify match labels. And labels really can be anything you want. In my case, I want to say app front end. So every single pod that has a label app front end is going to be controlled by this deployment resource. And of course that you're not restricted to a single label, you can have multiple labels. But here I'm gonna go with one label only. Then under Selector, we're gonna have template. And this template is basically the definition of a pod. So under template, I'm gonna have metadata. And don't confuse this metadata with this metadata. This metadata at the top, line 3, this is the metadata for the deployment. On line 12, this is the metadata for the pod, which is going to be controlled by the deployment. And then under metadata, I'm gonna define labels, because again, I need these labels for the deployment to select my pods, and I just need to make sure that it matches exactly what I put here. So the labels of my pod's gonna be app front end, and again, I could define more, but I'm just gonna define one. Then the same way as the deployment has a spec, a pod also has a spec. So under metadata, we're gonna define a spec. And this is where you define the containers for that pod. So you're gonna define containers here, which is an array. So let's start with the first item. Now for each container, we're gonna define the name of the container, which is gonna be front end. And don't confuse with the image. This is just the name of the container. Now we're gonna define the image. And this image is gonna be the one that you build in section number 1. So this is the URL of my ECR repo in my case. Then another important thing is which port the front end is gonna be listening for traffic on. So I'm gonna find ports, and ports is also an array because you can open more than one port. So the first item is gonna be container port. And my front end is expecting traffic on port 8080. So I'm going to define 8080 as container port. And then another thing is that you can give names to ports. And I'm just going to call it F port. Okay, so why this matters? This configuration file is relatively simple, but it can get way more complex than that. And when you start working with things like health check, for example, you're going to have to use this number multiple times in the file. And if you don't want to repeat yourself, you can refer to the port number by its name. So if I had more configuration and I wanted to indicate that I want to do something with port 8080, for example, create a health check, I can just indicate F port and Kubernetes will know that I'm talking about port 8080. So this definitely can come in handy. Then the last thing is the restart policy, which I'm going to set to always. So always restart my containers in case something goes wrong. And this is a little bit redundant because if I hadn't specified this, it would be set to always anyways. But I just wanted to show you where the restart policy would go. Okay, great. So this is the deployment definition of my front end. Now let me show you how you can use kubectl to deploy this. First, let me just go into the front end folder and then K8s. We can see our deployment.yaml there. Now all you gotta do is kubectl apply -f because we're gonna be passing a file, deployment.yaml. All right, it says it's created. Now to see the pod, you need to do kubectl get pods. And here you need to tell Kubernetes in which namespace you wanna see the list of pods. Because if you don't specify, Kubernetes is gonna try to get the pods from the default namespace. But remember, in my case, the name of my namespace is called team1. So I need to do -n, team1. And there it is. We can see our front end pod running. This is the name of the pod. Then under ready, it says 1/1, which means I defined one container and one is ready. If I had defined 3 containers, you would see number 3 here. And if all of them are running, you would see 3 here as well. Then under status, it says it's running. It hasn't restarted yet, which is great. So no failures. And then age, it just says how long ago I deployed the pod. Okay, so now what I'm going to do is exactly the same, but for the other microservices. This is the configuration file for the auth API. And it's really similar to the front end. The only difference here is that the image is different. So the repository name is team1 auth API and the port as well because auth API listens to traffic on port 8081. So these are all the difference and of course the labels. because I don't want this deployment to control the front end. I want this deployment to control the auth API. So I need to change the labels as well. So let's deploy the auth API. And instead of going inside each one of the folders, I can actually specify the path from here. So kubectl apply-f auth API k8s deployment. Next, we have the TODOs API. And then again, the image is going to change and also the port. But one thing you're going to notice is that now I have two labels. I have app TODOs API and also Redis access true. I'm not going to get into details as to why I'm defining this label. You'll understand once we get to section number 8. But because I have two labels for the pod, I also need to make sure that these two labels are defined under match labels for the deployment. So now deploying the TODOs. K8's deployment. Then moving on to users API. Also very straightforward. Let's deploy that. And lastly, log message processor. The labels for log message processor is very similar to TODOs API, but one thing that is different from all the other configuration files is that we're not defining any port for the log message processor. And reason being is because it does not expect anything to send any traffic to it. So that's why we're not going to define any port. Now, last deployment. So let's just get all of the pods again. All right, so I can see 5 of them. Although log message processor, it says crash loop back off. At this point in the challenge, that is expected because we do not have services set up. And also we don't have Redis running yet. So once we have Redis and we have services in place, the log message processor should run. But for now, don't worry about it. Most importantly is that the auth API, the front end, the TODOs API, and the users API, they're all running. And that was the goal of section number 3. Now in section number 4, we're going to learn how to set environment variables for each one of these containers and how we can store values for these environment variables using config maps and secrets.